Okay, we're going to do a quick demonstration on how to make a pasta rocket out of hydrogen peroxide, yeast, and a couple of household items, including ziti. First thing you do is take your hydrogen peroxide. This is just basic hydrogen peroxide like you get from the grocery store, 3%. You're going to fill up your small mason jar about 3/4 of the way, more or less to right below that line. Like that, right there. Right there is fine. Cap it so you don't spill it. And then you are going to take a piece of pasta. Try to pick out a nice straight piece. There's a good one. Okay, nice straight piece. Now, the cap for the mason jar, you should drill an 1/8 inch hole in it, and that lets the oxygen out. So, then you are going to take a 1/4 teaspoon of yeast, 1/4 teaspoon, and you are going to try to open the package. Okay, and you're going to put a 1/4 teaspoon of yeast in there. Now, you will pretty quickly start to see a reaction. Okay, get a little swirly, and it starts to bubble. Now I like to kind of break up those bubbles a little bit as they come up, because if I get too many bubbles, it's going to mess up my thingy up. So this is actually the start of elephant toothpaste here. If you use a different combination of, if you used more yeast, you would get more. No. Yep, see, it likes to bubble. But we got to get it before the oxygen runs out. So now what we're going to do is we're going to put this on top, and we're going to light the oxygen that comes out of it. And you can see, ooh, it's stuck to my finger. Don't do that. Alright, I guess I'm going to hold it. And you can see we get a nice rocket flame. So what's happening is the oxygen that's being created in here is burning with the solid fuel, which is the pasta. And you get a nice rocket flame. Now, if we were to put this on a scale, you could actually measure how much thrust you're getting from this very, very basic, oh, I should turn the fan on, this very, very basic rocket engine. And it'll just keep burning down until it's out of fuel, until it's either out of solid fuel or it's out of oxygen. Alright, looks like we're about to run out of fuel before we run out of oxygen. Now the yeast will actually continue to produce oxygen, but if I try it again, let's say, with a different piece of pasta, we probably won't get much of a result. And the reason is, it's just not producing oxygen at the same rate. Well, we'll get something. Got a little flame. So it's not producing quite as much oxygen as it was before. And now we're getting smoke. And this is why we didn't do this experiment in the actual school building. Woo, yeah, there's a good puff of smoke.
I can smell burning pasta.
Those are my children, by the way, who are here for the experiment as well. Say hello.
Hello!
So this time, the solid burned a lot more than the liquid. It's definitely still got a good flame, though.
It looks cool, like.
We'll try it one more time. Oh, it's stuck.
Wait.
All right, one more. Let's see how much oxygen it's still producing. This one's a little tippier. There we go. And then eventually it just won't burn because there won't be enough oxygen being produced. That's why it burned really well at first, but this time, yeah, I think it's about to go out. So what's going on here? Well, in our pasta rocket engine, we have our fuel source, which is hydrogen peroxide. It's a pretty simple molecule, and this is a drawing of it here. These two red ones are two atoms of oxygen bonded together. All right, that's that little yellow line. And then on either side of it, we have a hydrogen bonded here and a hydrogen bonded there. So we have H2, so two hydrogens, and O2, two oxygen. Pretty simple. Okay. Now, this itself doesn't burn. Hydrogen peroxide doesn't burn. Well, not that I've been able to get it to burn. So what actually happens is we put the yeast in it, and the yeast has this special stuff on it called catalase. You don't need to worry about what that is. Just know that it's this really complex protein that when the catalase on the yeast touches the hydrogen peroxide, it creates this chemical reaction. Now, during the experiment, after it's been bubbling for a while, feel the glass jar. You'll feel that it's warm. Because what's happening is the catalase is actually ripping apart this hydrogen peroxide molecule. And when it rips that molecule to pieces, it creates heat. So the chemical reaction creates heat. It also creates water. So two of the hydrogen and one of the oxygen goes over here, and we have a molecule of water. The other side, we get pure oxygen, which is O2. Now you're wondering, wait, where'd that other oxygen come from? We have O2, 1, 2, 3. Well, the one oxygen pops off, but immediately sticks to the next available bit of oxygen because oxygen doesn't like to be floating around just by itself. It's got to be in O2 form. Okay? So now we got water, which does not burn, and we have oxygen. Oxygen, yes, loves to burn. If you ever go to the hospital, you'll notice that if there's an oxygen tank nearby, there are big flammable signs everywhere. Oxygen, pure oxygen, loves to burn. And so that oxygen is what burns. So our liquid fuel becomes a gas fuel, and the solid helps burn the oxygen. And so when the oxygen runs out, or is just not enough of the oxygen to burn hot, the solid fuel won't burn anymore either.